welcome to Shine Tech's YouTube channel. In this video, we're going to look at homeostasis and thrombosis. So, normal homeostasis is a series of regulated processes that culminate in the formation of a blood clot that limits bleeding from an injured blood vessel. In this case, we are saying normal homeostasis is simply a regulated process that leads to formation of blood clot, and this blood clot is aimed at preventing bleeding from an injured blood vessel. But now thrombosis is simply formation of a thrombus, within a non-traumatized intact blood vessel. Okay, so we have a blood vessel, and then if we have injury to this blood vessel, then what will happen is that we have these processes which will just lead to formation of some clots there to prevent blood from bleeding out of the blood vessel. That is normal homeostasis. But now if we have formation of these clots in an intact normal blood vessel, let's say there is just a minor injury there, and then we start having accumulation of these clots on the blood vessel forming what we call a thrombus, then that will be called thrombosis. And then now normal homeostasis involves three most important things. It involves platelets, it involves clotting factors, as well as the endothelium. So those are the three main factors which are involved in normal homeostasis. Now let's move on and look at the events which occurs in normal homeostasis. So the first event which occurs in which leads to homeostasis is what we call arteriolar vasoconstriction. So arteriolar vasoconstriction, mostly it occurs immediately after injury. After endothelial injury, what will happen first is the arteriolar vasoconstriction. Then remember, this arteriolar vasoconstriction, it is transient. Okay, it is transient, and it is aimed at reducing blood flow. So it is aimed at reducing blood flow to the injured area. Okay, now what activates this arteriolar vasoconstriction? Mostly it is a neurogenic mechanism. It involves the neurons. After the neurons has activated this arteriolar vasoconstriction, now it will be augmented. It will be exacerbated by secretion of endothelin. So endothelin is a vasoconstrictor which is mostly secreted by injured endothelium. So the injured endothelial cells will secrete this endothelin. So this endothelin is a vasoconstrictor. It will lead to further arteriolar vasoconstriction. So as we can see in this diagram here, this is a blood vessel. Okay, so this is a blood vessel. Then in the blood vessel we have cells which are called endothelial cells. So those endothelial cells are the cells which covers the whole blood vessel like that. But if we have any injury to the endothelium, what will happen is that endothelin will be released and leads to vasoconstriction. That is the first step in the events of homeostasis. Then the second step of homeostasis is primary hemostasis. That is the second step, which leads to formation of a primary hemostatic plaque. Okay, so primary hemostasis leads to formation of a platelet plaque. Okay, the first thing, we have this disruption of the endothelium. We have injury to the endothelium. Now that injury exposes what we call von Willebrand factor. So the von Willebrand factor, as well as the collagen, will activate the platelet. So once the platelets are activated, they'll adhere to each other. They'll start attaching themselves. Okay, so we have this layer of endothelial cells. Okay, so we have a layer of endothelial cells. Then once we have anything that damages that layer, what will happen is that we have this factor which is called von Willebrand factor, which is exposed here. So it will be exposed there. So once it is exposed due to that endothelial damage, we have now these platelets which will come into contact with the von Willebrand factor as well as the collagen there. So that when they come into contact, So that connection now will lead to activation as well as adherence of platelets. So we are going to have more platelets now attaching to each other here, adhering and forming what we call a primary plug. So that is the second step, or the second event of homeostasis. Okay, it leads to formation of a primary hemostatic plug by platelet adherence only. Now in stage 3, or in event number 3, we have what we call formation of the secondary homeostatic plug. Secondary homeostatic plug. And then this begins now when we have what we call tissue factor. So it can be tissue factor or the same von factor. So the tissue factor leads to activation of factor 7. So factor 7 mostly it's in the coagulation cascade. The coagulation cascade, factor 7 is activated. Then we have this series of reactions which takes place in the coagulation pathway or coagulation cascade, which will lead to formation of what we call thrombin. So let me just show you how this factor 7 leads to formation of thrombin. Then, so clotting factor is exposed in the first place, remember. So clotting factor is exposed. So once this clotting factor is exposed, what will happen is that, so we have that tissue factor, not clotting factor, sorry, but tissue factor. So that tissue factor is mostly found in the endothelium, in the subendothelium. So once the endothelium is damaged, the tissue factor will be exposed. So the exposed tissue factor will activate factor 7. Most factor 7, these are coagulation factors, okay? They are in blood. So this factor will be activated. So once it is active, okay, due to this tissue factor, then factor 7 will activate factor 10. So active factor, not factor 10, but factor 9 in short. So factor 7 activates factor 9. So factor 9 now will activate factor 10. So the active factor 10 will activate prothrombin. So prothrombin is the inactive form, then the active form is thrombin, okay? So prothrombin will be activated by factor 10 to thrombin. So this thrombin is very important. It's the one now which cuts the fibrinogen into fibrin. So fibrin is the one which we need to form a secondary hemostatic plug. Okay. Now let's go back. We have seen how this factor 7 there leads to formation of thrombin. So that thrombin, we saw that it activated fibrinogen into fibrin. So here, remember, fibrin is very important. Now this fibrin will form what we call a fibrin meshwork. A fibrin meshwork. So remember, we have these fibrin threads, okay? And then these fibrin threads, remember as well, this thrombin can also activate platelets. So it activates platelets as well as leads to formation of fibrin, which are these threads-like structure here. Okay, so those threads-like structure, they will trap platelets there. Okay, they adhere to the platelets. Okay, leading to what we call secondary hemostatic plug. Secondary hemostatic plug, as we can see in this diagram here. So we have the tissue factor, activated tissue factor due to injury, okay, of the endothelium. So we have the endothelium there, it has been damaged, and then tissue factor is exposed. The tissue factor will lead to formation of what? Thrombin. So thrombin has been activated. Now the thrombin will lead to fibrin polymerization. So formation of fibrin will now adhere to the platelets, forming what we call a secondary hemostatic plug. So that is step number 3. Now in step number 4, it's mostly what occurs here is a counter-regulatory mechanism. Okay, remember that cascade, this cascade here, what is happening here, formation of these clots, if not regulated, it can lead to formation of clots, which can also lead to obstruction of this blood vessel. But now we have what we call clot stabilization and resorption. That is event number 4. Mostly this is a counter-regulatory mechanism. So it involves 2 things. It involves tissue plasminogen activator and thrombomodulin. So the tissue plasminogen activator causes fibrinolysis. So those fibrins which are formed in the blood vessel, some of them, they are lysed by the tissue plasminogen activator. So what it will do, some of them, instead of activating platelets further, adhering to platelets further, there is this tissue plasminogen activator which will now cause lysis, fibrinolysis of those fibrin. Then apart from that, another counter-regulator is thrombomodulin. So thrombomodulin, we said we have those factors, factor 7, which are activated. So it will block activation of coagulation cascade. So the coagulation cascade, once it is blocked, there will be no formation of the thrombin. So if thrombin is not formed, meaning even the fibrin will never be formed. So meaning the clots won't be formed. So this is a counter-regulatory mechanism. So now let's look at what really happens in the activation of platelets, how these platelets are activated. So platelets are activated when the subendothelium is exposed. Okay, so the endothelium, the layer which lines the blood vessels, it has the endothelium inside, and then it has the subendothelium. Okay, the subendothelium. So in the subendothelium, which is this layer here, there is what we call von Willebrand factor. So this von Willebrand factor, once it is exposed, in blood, as blood is circulating, there is millions, thousands of these platelets. So now those platelets will be in contact with this von Willebrand factor. So once they are in contact through the receptor on the platelet, which is called glycoprotein receptor 1b, they will be in contact. Once they are in contact there, the platelets will be activated. Then once the platelets are activated, they will change their shape, and then they will release what we call granules. So there are 2 granules which are released here. So we have the alpha granules and the dense granules. Okay. So the alpha granules, there is what we call fibrinogen, okay, in the alpha granules, and then there is also factor 5, and then there is also fibrinogen as well. Then there is von Willebrand factor. So remember, von Willebrand factor can also be released by the activated platelets in the alpha granules. Then in the dense granules, which are released by activated platelets, there is ADP, ATP, there is also ionized calcium, there is serotonin, there is also epinephrine. So the ADP, this one here, which is released by the activated platelets, okay, adenosine diphosphate, will cause conformation change. It will change. Remember, these are spherical, so they will become spiky. Okay, they will change their shape once they are activated. So the ADP induces conformation change, and then remember the fibrinogen is also released by the alpha granules, which are released by the activated platelets. So the fibrin will also lead to the link, okay, attachment of these 2 platelets together is facilitated by the fibrinogen via what we call the glycoprotein receptor 2b and 3a. Okay, so these receptors there. So those receptors will lead to attachment via the fibrinogen, okay, forming a link between those platelets. Okay, so remember these activated. So this one, Once active, will release ADP, and it will also release fibrinogen via those granules, and it will also release von Willebrand factor. It will also release factor 5. So those things which are released will further activate other platelets, okay, leading to a cascade of reactions which will lead now to formation of a clot here. Okay, that's how it is formed. Then now event number 4, that's where now we saw that we have these two things which will regulate, which will counter regulate that mechanism. Okay, so we have the tissue plasminogen activator as well as the thrombomodulin, which blocks the coagulation cascade. So thank you so much for watching. In my next video, I'm going to look at thrombosis as well as the coagulation cascade.